Hi there, so we've had a question in from Kirsty about questions 9 and 10 from exercise 1D. I'll note that there actually, so this is 1D in the further maths, as to how to do these two questions here then. So we just need to transform each of these two statements here into equations first, and then we'll find our way towards a ratio. So y is 20% greater than x. If I take x and increase it by 20%, I'll get y. And if I get something, that's equal to it. Okay. So to increase something by 20%, we'll use a decimal multiplier. So to increase something by 20%, we'll multiply it by 1.2. Okay. So if I took x and multiplied it by 1.2, I would get the value of y. Okay. And this is why in my intro video I sort of said things you thought you know well, can you apply it in this new context? Okay, so we'll start with something simple like this. W is 20% less than y, so if I took y and times it by 0.8, that would give me what W is. Okay, so if I want to decrease something by 20%, I'm actually finding 80% of it. 80% as a decimal is 0.8. Okay, and then not obviously, I guess, but let's change these into some nicer numbers. So this statement here, let's bring it down here. So I could write 6/5 is 1.2 of x equals y, and then I could rewrite this as 6x equals 5y. Okay. Similarly here, I could write 4/5 of y equals w, which implies that 4y equals 5w. Okay, so now we have these two equations. We can now move on to the next step, which you might have guessed that now. That might be all you need, in which case crack on and get the answer done, but I'll carry on going. Feel free to stop and do these questions at any point. So I get loads of emails through here. So we want to now move this through to ratio. Okay, so 6x equals 5y would imply a ratio of y to x of 6 to 5. Well, why is that? Okay, well, if we think about what we would need, so if I have 6 lots of x gives me 5 lots of whatever y is, what would make these the same? So for instance, if I times or if I let y equal 6 and I let x equal 5, then it would be true that they both equal 30. So we can move from an equation back to a ratio just by deciding how many of each of y or x I would need in order to make this equation true. Okay, and a little shortcut, as you can kind of see here now, is you just switch the numbers around. So 6x and 5y, you end up with 6 lots of y and 5 lots of x to make them equal. Okay, and therefore gives you the ratio. So again, we can make the jump now. So if we go back over to the 5y equals 5w, then this must be in the ratio of y to w, 5 to 4, i.e. 4 times 5 for the y will give you 20, and 5 times 4 will also give you 20. Now if I line these up nicely next to each other, I've got an x to y, and then I've got a y to w. So just 5 to 6 and 5 to 4, just switching those two round there. And then what we need now to have two, scroll down slightly, there we go. I now need to be able to, in order to compare x to w, I need to have the same amount of y's, okay, because then I can say, well, if that many y's is this many x's, then that must also be the same amount of w's, okay. So I need the lowest common multiple of 6 and 5, so 30 for instance. So if I scale this up to 30, I'll have to times this one by 5. So keeping the ratio in the same proportion over here, we'll keep them in the same ratio, I get 25 x's. And then similarly for w, times this one by 6 to get up to 30, so we get 24. So these two parts are now equal, which implies that the x and w's would also be equal. So then x to w equals 30, sorry not 30, 25 to 24 there, okay? So I'll carry on going, but pause the video, have another go at 10 now with that idea in mind of how you can go from percentage, decimal, multiplier if it's appropriate to an equation, to a ratio, and then see if you can get the answer. Okay then, so for question 10, do it ever so slightly differently just by jumping out a few steps. Hopefully you got the answer right after watching the first one. So this time we can't multiply by a decimal because we've got m. We can't call it 1.m or something like that, doesn't really make any sense. But we do know that we can change a quantity into a percentage, so now we have to deploy perhaps like a non-calculator, or maybe one of the first ways that you would have used to find a percentage. Okay, so if p is n% greater than q, we would start with q and then we would add on this m%. Okay, now if I wanted to find m% of a number, I would take that number, which is still q, divide it by 100, which finds me 1%, and then times it by that percentage. Okay, so if we had like q was 40 and we wanted 20% of 40, I would do 40 divided by 100 for 1% and then times it by 20. Okay, so this is how we would do it if we just replace that with letters. So this is equal to p. Okay, so p is whatever q was plus n% onto that. Okay, so the next statement, p is n% less than r. So I take an n% away from r and I'll get p again. So this time p equals r minus r over 100 times by m. Okay, so again I'd start with r and then to find the percentage of m, divide r by 100 and times it by m. So now we're going to just do it slightly different. We're going to miss out a step rather than sort of playing around with the fractions that we've got here. Both these two things are equal to p, and if you think eventually I want an equation with r times something equals q times something, and then I can write them as a ratio using the ideas that we had before. So they're both equal to p, so they're equal to each other. So we can say q plus q over 100 times m equals r minus r over 100 times m. Okay, and then ideally, going back to this idea, we want r times something and q times something. Because we've got those multiplications, then we can find that ratio equivalence. So we can get that by factorising out q. So we get q and then 1 plus m over 100. Okay, so q is times 1 here and times by m over 100 here. Think of this as m over 1. So I'm just taking out taking out that q, and you'd be left with 1 times m and then 100 times 1, so you get m over 100. And then this would be equal to r, and same trick again here, 1 minus m over 100. So now we'll set ourselves up. What would q to r be? Rub this out from before. So so in order to make them equal to each other, okay, so like last time I had like 5r equals 6q or something, you just multiply them by the opposite number to find the lowest common multiple. In that case, when it was 5 and 6, it made 30, and we don't know what the lowest common multiple is of these two, so we'll just do what we do with fractions and just cross multiply. So it would be 1 minus m over 100. Oh, sorry. M over 100 to 1 plus m over 100. So you can see I've switched those two around to get the ratio. That's why I'd have to multiply the other one by to make these two things equal to each other. So this would have 1 plus m over 100 times 1 minus m over 100, and then conversely this one would have 1 minus m over 100 times 1 plus m over 100 to make them equal on both sides. And then to get the answer in the book, if you just times both sides by 100, because it's a ratio, you can do that. You will end up with 100 minus m and then 100 plus m. I think it asked it for the way around, r to q, so that's why I think the answer in the book is the other way around there. Okay, so I hope that helps, and if not, then just email me back again.